In 1785, the United States was still a fragile nation, newly independent. Yet bound by an invisible chain public debt, the Revolutionary War had left behind more than scorched fields and exhausted soldiers. It created enormous financial obligations to France and to domestic creditors. At the time, the federal Congress had almost no authority to impose direct taxes. They possessed land millions of acres west of the Appalachian Mountains, but land did not magically turn into money. Under relentless financial pressure, waiting for slow survey expeditions to measure every stream or oak tree was not an option. They needed a system, an algorithm, a way to convert wilderness into units that could be identified, valued, and sold in bulk. That idea became law in the Land Ordinance of 1785. Behind its logic stood one of the defining minds of the Enlightenment, Thomas Jefferson. What he proposed was more than a map. It was a massive spreadsheet stretched across the earth, where each square represented an asset, and every coordinate functioned like a line of data. But to understand why this idea was revolutionary, we must first look at the system it replaced. Before 1785, land division in British colonies relied on a method known as métis and bounds. Instead of fixed coordinates, boundaries were described using natural landmarks from the large oak by the creek. Walk 40 steps toward the granite boulder. Then follow the stream to the forest edge. At first glance, this approach felt organic and closely tied to nature. Legally, however, it was a nightmare. Trees died, rivers shifted course after floods. Stones were moved or disappeared. When natural markers vanished, boundaries became ambiguous, and ambiguity in land ownership meant endless disputes. Throughout the 17th and 18th centuries, colonial courts were flooded with land cases. The problem was not greed, but the lack of standardized measurement. In mathematics, changing the reference frame alters the entire outcome. Mates and bounds depended on memory and landscape, two things that are never permanent. Jefferson, shaped by the intellectual climate of the European Enlightenment, understood that a modern nation could not rely on collective memory to define property. It needed an abstract, stable, and repeatable system. In other words, it needed a coordinate grid. This was the moment when geometry became a political instrument. The 18th century was an age of faith in reason. Thinkers like John Locke and Montesquieu believed society could be designed rationally. Almost like a machine, Jefferson absorbed these ideas deeply. He envisioned a nation of independent farmers, each owning enough land to remain self-sufficient, free from the aristocratic landlord systems that dominated Europe. But fair distribution required a standard unit. The Land Ordinance of 1785 divided land into square townships, each 6 miles on a side. These were further split into 36 sections, each 1 square mile. A square mile equals 640 acres, large enough for a family farm under 18th century agricultural conditions. Mathematically, this created a highly scalable hierarchy, from township to section, down to quarter sections of 160 acres. Everything was a multiple of a base unit. Standardization made land easier to sell, to record, tax, and transfer. Geometry was no longer confined to textbooks. It became the language of finance. By turning land into uniform squares, nature itself was transformed into data, and data can be traded. In that moment, America began to be rendered from a mathematical idea. What made this system remarkable was that it was implemented before settlers even arrived. Survey teams went ahead, placing markers and drawing grids. On maps in Philadelphia or New York, perfect squares appeared as if the western lands had already been tamed. In reality, those territories were still forests, prairies, and the homelands of indigenous peoples. Drawing grids before human settlement was a powerful symbolic act. It converted unknown land into property that could be defined from afar. In economic language, this was commodification. Once something receives precise coordinates and measurable area, it can be bought and sold like any other product. The doctrine of manifest destiny. The belief that Americans were destined to expand westward found its perfect tool in this grid system. Geometry here acted like light in a dark room. It did not change physical reality, but it changed how people perceived and owned it. An unnamed landscape became Section 12. Township, 3 North. A technical label yet enough to sign a contract. And once contracts were signed, money began to flow. 2 centuries later, the marks of the 1,785 decision are still visible from space. Roads intersect at right angles. Square fields stretch toward the horizon. This system helped decentralize power. Individual farmers owned separate parcels instead of depending on tightly clustered villages like those in Europe. But the cost was social isolation. Homes were spread far apart. Communities dispersed. The checkerboard pattern became not just a visual landscape, but a social structure. Philosophically, this reflected Cartesian logic. The world could be divided into discrete, measurable units that could be managed independently. Yet nature does not follow right angles. Rivers curve. Hills rise unevenly. The grid sometimes cuts through valleys or splits ecosystems in half. The paradox is striking to create individual freedom. America imposed an absolute geometric order onto its landscape. As a result, the United States was not built along ancient historical paths like older civilizations. It was designed like a vast data model where each square represented a financial promise, a dream of ownership, and a political decision. Perhaps the boldest part of this story is not the straight roads or square fields. It is the belief that a nation could be built from an abstract idea, a spreadsheet, stretched across an entire continent.